Okay. Now let's take you back to tutorial. You remember we already solved question 1. Sorry. Question 1, question 2, question 3, question 4. Conversion or system number of different system numbering. Now, question 5 talk about convert each hexadecimal into binary and give me here A14, A14 and FB17. Okay, I will work in the next slide. Now, just to remind you, remember we mentioned that when we want to convert hexadecimal into binary, each number represented by 4 digits, right? 4 bits or a nibble. So when I come to A 1 4, this is already solved. Okay, 16. 4 will be represented by 4 digits. 1 will be represented by 4 digits. A will be represented by 4 digits. And starting from here 1, which will be 4 from the least significant bit, which will be represented as 0 0 1 0. You can see here 0 0 1 0. 0 here is the ones. And the second 0 is the 2s, the third 0 is the 4th, and so on. So this is 4. And the second number is 1, so I represent it by 1 0 0 0. This is 1. And A is 10. In hexo, A is 10. So I will represent it by 0 1 0, no 0 0 1 0 1. Just let me check. This is 2. This is A, 10 plus, okay, 10. So this is A. So the new number will be 1 0 1 0 0 0 0 1 0 1 0 0, and here is the binary. Okay, 2s, right? You see here, these are the first 4, these are the second 4, these are the third 4. Now, this is for the first number here. Again, when we want to convert hexadecimal into binary, each number represented by 4 digits, and then we put them together starting from the least to the most significant bit. Now, the second number here, okay, is FB17. Can you start working on this before I solve it? You have a couple of minutes to do it on paper. Start working on this one. Okay. As you know, B is 11 and F is 15. Home finished.
Yes, Doctor, finish.
Finish? Okay.
Yes.
Then let's start working together. Okay. 7 will be represented here, and 1 will be represented here, B here, F here. 4 7, it will be 1, and this is 2 3, and this is 4, it will be 7. And 4 1, it will be 1 0 0 0. B is 10, right? So it will be 0 1, which is 2, 0 1, which is 8, 10, 8 plus 2, 10. 4F, which is 15, all of them here. So this is represented in binary. Is it clear how we convert from hexa to binary? Clear?
Yes, Doctor.
Yes, so what we should do in if we want to convert from hexa to binary, each number represented by how many digits?
4 digits.
Excellent, 4 digits. Now, if he asked me to do the opposite, I mean, he gave me binary, he wants me to do hexadecimal. What should I do?
We will convert each 4 digits to a number.
Excellent. We started from the least significant bit or from the most significant bit. From where we start? Least or most? From the right or from the left we start? Okay, from the right. I mean, as example,
Right.
excellent. As example, if you can see here, we started, this is the first number, and this is the second number. The first number here is 2 plus 4, 6. The second number, 2 plus 8, 10. And this is hexo, so 10 mean A. So this number is A, 6, and the base is 16. You see? How much the second number? You tell me.
The first number will be 0.
Yeah. This number is 0. The second number, this number, how much? How much the second number? What do you think? It's F, it's 15, right? 1 plus 2 plus 4 plus 8, 15. Now, I have here 2 ones. I need to add here to the left another 2 zeros to make it 4 digits, to represent it by 3. So the number will be 3 F0. Excellent. And this is 16 digits. Now we converted from hexo to binary, from binary to hexo. Let's go for conversion from hexo to decimal. Hexo to decimal. Okay. Can you start working on the first one? Start work. You remember when we convert to decimal, always we multiply numbers by the radix or the base rises to power 0, to power 1, 2, and so on. We did it in binary, in octa, and in hexo. So this is to be solved first by you, and then I will start working on it. How much will be the first part, which is 23? Check it.
Doctor, the first part will be 35.
Okay. The first part will be 35. Okay, let's work together on this. So he told me 16, it means 3 times 16 rises to power 0 plus 2 times 16 rises to power 1, which, as you said, I expect it to be 35. Now, the second one is hexo, okay? So we will come to write it in this way. 5 rises to power 16. I will put the power later, plus C, which is 12, right? C is 12, rises 16 rises to power, I will put it later, and 2 rises 16 to power 0, here 1, and here 2. The result expected to be how much? Can you help me with calculator? What do you think?
1474.
Excellent. Put it in a box. My advice here, when you work for similar problems here, if it is exam problem, try to find the result of this multiplication, the result of this multiplication, and the result of this multiplication, and then you add. Don't do the whole operations all together in the calculator. You may get mistakes, right? It's preferable to work in steps, don't jump. Okay. Now this is for conversion of hexadecimal number to hexadecimal number. Now convert decimal to hexadecimal. In general, just to remember what we discussed in week number 1. Do you remember when we said that if we want to convert from decimal to any other numbering system for integer numbers, what we should do? Divide or multiply? What do you think? Do you remember? We divide, right? Excellent. We divide.
Yes.
We divide and we take the remainder and then put them from the least to the most significant bit. As example here, if you see here 14, if I divide it by 16, I cannot. Okay, I mean 14 is lower than 16, so 0. The remainder is 1. Okay, so in this way, there's the same thing here. 2, 8, 4. Remainder is 14, definitely. 14 remainder. Sorry, not 1. Remainder is 14. The result is 0, and the remainder is 14. So I will say 14. It means E. It's equivalent to E. E in 16, in base 16. As you can see, this is in tens. Okay. Usually, either you put line here to make division, or directly in this way, as we learn in week number 1, 16. Then here 0. Remainder is 14. Okay, and then that's it. Since it's 0, we cannot go further, and this will be the least significant, but there is no other number to say that least or most directly. But here, as you can see, okay, or let me work in the same way in week number 1. 284 divided, definitely, sorry, divided by 16. Okay, here is the integer, here is the remainder. Okay, now you divide 284. How many 16 in 284? But make sure that you get integer here and remove the remainder. Okay, I will tell you, I will take the numbers here from the paper. 17, we get 17. Okay, 12 here, remainder is 12. It means what I did, I subtracted 12, because if I divide 284 divided by 16, I have a fraction. 283 divided by 16, another fraction. 282, 281, 280, and so on. I try to subtract until I get integer number. So when I subtract 12 number, which is the remainder, then what is left? Let me say 284 minus 12, it means 272. So when I divide 272 divided by 16, it gives me 17. You see? And this is the remainder. This will be the least significant bit. I go further. 17 divided by 16. Okay, we have 1, and the remainder is again 1. Okay, 1, 16, we cannot, and so on. So this is 1. Remainder is 1. Okay. So then we write C 12. 12, is it A or B or C or D or E or F? Which one of them in Hexo?
C.
So we will write C. But you see here, this is the least significant bit, and this came second, and this came first, third. So this is, as you remember, this is A0, this is A1, as we discussed before, and this is A2. In this way. convert each decimal. We solve this one. Convert each octo number to decimal number. Now, I leave this to you to start working on it, both of them. It's clear that we will multiply by 8 to power 0 to power 1 to power 2. So work on it and tell me how much 12 will be in decimal. Did you find it? And
It will be 10.
the first one will be 10. What about the second one? I will work on first one while you are doing the second one. So I will say 2, 1 by 8 to power 0 plus, sorry, to power 1 and 2 by 8 to power 0. This give me 2, this give me 8, and this means 10. Okay. Now let's do it for the second one.
Second one will be 67.
Will be 67.
67. Let's do it together. We will say 3 times 8 to power 0 plus 0 times 8 to power 1 plus 1 times 8 to power 2. Now this one will give me 3. This one will give me 0. This one will give me 64. 64 plus 3 will give me 67. You are right. Now let me improve this question. If I ask you to convert this octa not to decimal, to binary. If I ask you to binary, 12 will be in binary from the least significant bit.
Each number will be represented by 3 digits.
Excellent, 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 Assam. Assam, right?
Yes.
Great. Well done, Assam. So 0, 1, 0. And the second one is 1, 0, 0. You see here? This is 2. Tell me about this one. Yeah. From the right.
110.
1, 1, 0. Then
000. 000.
0, 0, 0. Then
100.
excellent. You see, when we convert into binary, we know the rule, we just need to apply it. Okay, let me take another question. Convert octo into decimal, convert decimal. Now we are here. Okay. Okay. Now he asked me to convert, and this is a question. Okay, he asked me to convert decimal into octa. So as we discussed before, we divide, right? I mean 27 in this way. 27 divided by decimal, sorry, into octa, divided by 8. Okay, here the integer, and here the remainder. And then we start taking the numbers. Now 27 divided by 8. Let me take the numbers. What do you think? How many 8 in 27?
3.
3. So 3. How much the remainder? Because 3 by 8, 24. How much the remainder here?
3.
Right? 3, right? Great. Now, next is 3 divided by 8. Can we? We cannot. So 0 integer, and the remainder is 8. Right? So this is the least significant bit, and this is the most significant bit. I mean A0, A1, or write it in this way. Right? Now let's apply this. Did we convert? Yeah, this is converted. Now, can you convert 100 and tell me?
It will be 144.
Sorry, the reminder is a 3, not 8. Sorry, the reminder is a 3. Okay. How much, Sam?
144.
144. And the base or index is 8. Let's do it. Let's do it together. We will repeat the same. I will use here the same plate. Okay. 100 divided by 8. It will give 4. No.
12.5. 12.5.
Sorry. 12. No, we should have integer 12, and what is the remainder?
0.5, which is 1, it means.
No, not in this way. 100 divided by 8, it should be integer and there is remainder. As example, 12, now you say 12. 12 times 8, how much it give? 69, right? Sorry, 96, right?
Yes,
96. How much left from the 100? How much left from the 100? 4.
4.
So the remainder is 4, right? Now I take 12 divided by 8. You see, 12 divided by 8. How many? We have 1. How much the remainder?
Will be 4.
4.
4 will be, yes.
Now 1 divided by 8. We cannot 0, and the remainder is 1. So now this is A0, this is A1, this is A2. I write them in this way: 4, 4, 1, and the base is 10. Sorry, 8, because we are converting to octa. Yeah.
Octa.
Now, if you ask me to convert now octa, he gave me this number you see in octa. Okay, to binary. What should I do?
Each number will be represented by 3 digits.
Excellent. So this one, you tell me what should I write from the right? What should I write here? You tell me. 7 will be 1, 1, 1. And what about 5? 1,
0, 1, 1.
Excellent. This is the binary. Okay. Now what about this one? Okay. Let's work together. 1 will be 1, 0, 0. And 0 will be 0, 0, 0. And 1 will be 1, 0, 0. This is clear?
Yes, doctor.
Okay. Ladies, are you copying? This is clear? Okay. We solve this 10 and 11. Let's go for 12. Convert each binary number into octa. You know the rule now. You say that every 3 digits represented by one number. So this first 3 digits represented by 1. The next 3 digits represented by 5. We just put them in brackets and write here the regex. What about this one? This is the first 3, the second 3, the third 3, the fourth 3. This is 2, right? What about this? 1, 0, 0, 1?
4.
4. What about this 0, 1, 1?
6 will be.
6. What about this 0, 0, 1?
4.
4. Again 4. So this is the number in octal. Easy? Clear?
Yes, doctor.
Okay. Now we're approaching this point. Until this point, I think we stop here. Okay, and we will continue solving other problems because I approaching the operations now, addition and subtraction. So we will continue in the afternoon, inshallah, session. Do you have any question to this point? Any question? I will.
Thank you, doctor.
Thank you very much. I will upload the record